Okay, so if we want to apply our knowledge of transformations to help sketch our graphs, don't forget we've always got our fallback, know the general shape, and then find our x and y intercepts. So a key approach will be to try to write the coefficients of the y and the x values as 1. So if we just rewrite this one, let's rewrite this as y equals negative square root of that negative 3. Let's take that out the front. So let's go negative 3 outside of, we'll call that, becomes a positive x there now, and we'll make that a negative 2/3 plus 2. So from here it's a bit easier to see. I've got a reflection here. So that negative there is about the x-axis. This reflection here about the y-axis. That's a dilation factor, which just means our graph's going to be a little bit fatter or skinnier. It's actually dilated by a factor of 1/3 from the y-axis. Shifted 2/3 units to the right and 2 units up. So we know the basic shape of our square root graph is that. Okay, so let's have a think. So we know one reflection takes it that way, another reflection takes it that way. So there's our two reflections. Now we've got to shift it 2/3 across and 2 units up. So my starting point, if you like, is 2/3 across and 2 units up. So let's just call that 2/3 across and 2 units up. And you would imagine the x-intercepts and y-intercepts are something like that. Okay, but we can confirm that. X-intercept. No, let's put the y-intercept. Y-intercept, let's put x equal to 0. If I put x equal to 0 into the original equation, I get f of 0 is equal to negative square root of 2 plus 2. So 2 minus root 2, well, the square root of 2 is somewhere between root 1 and root 4. So it's somewhere between 1 and 2. So it's a small positive value, which seems reasonable. 2 minus root 2. Let's sneak down here, perhaps, for our x-intercept. So I'll put y equal to 0. So let's put negative 2 is equal to negative square root 2 minus 3x. They cancel. We'll square both sides. 4 equals 2 minus 3x. So if we rearrange that, I'm going to have negative 6, positive 2 equals negative 3x. So x will equal negative 2/3, which again seems reasonable. The domain of the function, well, we can see we moved it 2/3 across. So my domain is going to be, I can have positive 2/3 minus infinity. The range of this function, we can see the maximum value there is at 2, so I might go there. So we're going to have from negative infinity to positive 2. Okay, so hopefully that domain 2/3 is a bit more obvious there, where we try and write the coefficient of our x value as 1, just to see we have gone 2/3 across. All right, just check that on your CAS calculator to make sure we're happy with that result. If we do the same thing here for question 2, again, I'd be writing it as y equals negative 1 over, let's put that negative 3 out the front. That makes it a positive x, and we're going to have a negative 2/3 minus 1. So probably don't need that first little bracket there. It's probably a bit confusing. So what does that mean? Well, the negatives can cancel. So we're going to end up with a dilation factor there. We could look, it could be a third. We could call 3 a third from the y-axis from the x-axis, sorry. So we could rewrite that as y equals 1/3 over x minus 2/3 minus 1. It's not crucial because we haven't been asked to describe the translations. We just need to know what they are. Clearly, it's been shifted 2/3 to the right. So my asymptote is at 2/3. So let's put the x equals 2/3. And we've been shifted 1 unit down. So y equals -1. And with the positive, we've ended up being in the same original quadrant. So my graphs are going to be that section there and that section there. Now, we've sort of run out of room, so we're expecting my x-intercept to be positive. So let's look for some intercepts. X-intercept, y is equal to 0. So if we go to the original equation, 0 is equal to -1 over 2 minus 3x minus 1. So let's plus 1 across. -1 over 2 minus 3x, multiply 2 minus 3x over. What are we going to do now? Let's take the 2 across, so -3x equals -3, so x equals +1. So if that's 2/3 there, +1 there seems reasonable. Let's go for the y-intercept and put x equal to 0. So I'll get y is equal to -1 over 2 minus 0 minus 1. So y equals -1/2, which equals -3 on 2. And if my asymptote is at -1 there, an intercept there at -3 on 2 as well also seems reasonable. Okay, so you can get a feel. You've got to know your basic shape, and then with a little bit of reflection and translation, you can find your key points.